Hello everyone, my name is Engineer Holiday. I'll be talking about inclined plane, which is a simple machine or a machine that is drawn like this. Now in this machine, it is majorly used to raise a load, to lift a load up. For example, if you want to lift your drum of oil into the floor of a lorry, you can use an inclined plane. Let's say this is a lorry, a rough sketch, and the drum is here. You can actually place an inclined plane inclined to the back of the lorry at an angle to the ground and actually roll your drum in that inclined plane to the floor of the lorry, which is this part. So we can also use it to raise cars. When you want to drive cars from one particular place to another, you want to take this car to another location, you can drive it. Just place a plank at an angle to the floor and use it to raise it to the floor of the wall so that the car can be at the back of the lorry. So all these things, because it's very difficult for you to raise this car with your, maybe gathering your friends and every other person to lift it up to come here. No, it will not be easy. But if you slant incline a plank to the back of the lorry, and then somebody drive this particular car through this plank, they will get to this floor. Now, apart from that, we know that mechanical advantage is equal to velocity ratio if the efficiency of this particular incline is equal to 100%, meaning that this is the angle. Let's say this is the load M or the mass M, that's the weight mg. Now this from here, let's call this one OXY. Now OX is what we call the length of the inclined plane. Then XY is the height of the inclined plane. Now, if you want to calculate the velocity ratio, now if you say MA equal to VR when efficiency is 100%, that means it is assumed that friction is less than, or let me say equal to 100%. So if friction equal to 100%, if efficiency equal to 100%, that means it is assumed that friction is what? Is negligible. I'm sorry, friction is negligible. So if friction is negligible, then efficiency will be equal to what? 100%. Now, that means that we can also assume that the plane is smooth in that case, in that regard. But the danger about having a smooth inclined plane is that the car that want to move will be difficult. It will be difficult for proper gripping of the tire and the plank. But if the plank or the inclined material is rough, like if there is friction on the surface of the plank used as inclined plane, then what will happen is that it will not be that if there is a friction between this surface, it will enable the car to actually move from one place to this end and even get to this back floor of the lorry. Now in that case, now don't forget, friction enable movement. So if you are using a smooth plank, there is a danger for the driver driving this one because there will not be proper gripping of the tire and the plank. But if there is friction now, that means that mechanical advantage will be less than what? Velocity ratio. And thereby efficiency will be less than what? 100%. Now, if efficiency is less than 100%, first, what is the definition of velocity ratio? It is distance what? Of effort over distance of load. Now, what is the distance of effort? Distance of effort is OX, while distance of load is XY, which is the what? More or less like saying what? This is the length, let's call this one length of the plank, OX. OX is the length. Then this one is the height. From here, the height of the inclined plane. So in that case now, what we are actually saying, we know that sine theta is equals to opposite over what? Hypotenuse. Opposite over what? Hypotenuse. So if that is what? The formula for what? For sine, which is xy over os. So what we are having here is the inverse of sine. So velocity ratio, because this is the distance moved by the load, this is the load itself, is the one moving along this plane, that is the distance moved by load. Why the height is what? From the ground level is the distance moved by the what? No, this is distance moved by effort rather, because the person is applying a force to pull it up, is applying an effort to take it up, while the height is the what? Distance that be covered by the load, because you are taking it from the ground to the floor. So from the ground to the floor is the height you have taken the what? The load, the car to. So that means that this height becomes what? The distance moved by the load, while the effort is made to bring it from this point to this point. So that is what? That. Now, what if you relate these two formula, you notice that it is equal to what? Sine theta, 1 over sine theta, meaning that inverse of this one is equal to this one. Meaning that we can write this one as 1 over xy over ox. That's what it means. So if you take this one now, you are going to have this one. So because the os will go up, and this one alone is equal to sine, therefore 1 over sine, which is also known as cosec theta. Cosec theta. Now we have talked about that. What about the mechanical advantage for a machine, a inclined plane that is under friction, if there is friction? Now we know that the load over what? Effort. Don't forget, in the case of frictionless surface, as I said before, your MA equal to VR. That means it will not be equal to 1 over sine theta. So sometimes this velocity ratio 1 over sine theta can be given to mechanical advantage in a frictionless surface. That means an inclined plane that is frictionless. Now, but in the case of friction that we have talked about, let's see what is the load. The load is equal to what? Mg, which is mass times gravity. That's what the load is. Mg. Now, what about the effort? Because there is a friction, so there is a friction along the ground. Because the motion is trying to move the body upward, there will be friction here that try to oppose the motion of this body of mass M. Now, another thing again that acts here along this side is what? Gravitational force, which is what? Mg sine theta. Gravitational force along the inclined plane. There's another gravity here which I'm not concerned with here, mg cos theta. If you resolve this particular one, we have a angle theta here. If you resolve this theta to this direction, to the normal, at 90 degrees to the surface, to the inclined surface, it is mg sine theta. But along the what? The inclined plane, it's mg cos theta rather, perpendicular to the surface, but along the plane, it is mg sin theta. Now, what we end up having is that the least force that this man pulling or the effort can apply to move it up the plane is what? Is the effort we call mg sin theta plus frictional force. That is the least effort this person can apply to move this body of man is the frictional force plus the gravitational force. So which is equal to what? Mg sin theta plus frictional force, where Fr is what we call the frictional force. While what? Mg sin theta is what we call the gravitational force along the plane. Now, I want to understand that now. What I want to do now is that since our mechanical advantage then becomes, the mechanical advantage now becomes what? Load, which is what? Mg over what? Mg sin theta plus Fr. Under friction, when we go and check our video on friction, where we explain this, just go to my YouTube channel and check friction. So that is what? The mechanical advantage. Now, having known the what? The friction, the velocity ratio, and we have also known the what? The mechanical advantage. Then what is left for us to now do is to calculate the efficiency of the inclined plane. So how do we calculate the efficiency of the inclined plane now? So what we do is to combine what? Efficiency equal to mechanical advantage over velocity ratio. You have to go and watch the video of this particular efficiency of a machine. Now, when you get that, for continuity sake, now it will now be mg over divided by mg sin theta plus Fr, which is the mechanical advantage, divided by velocity ratio is what? 1 over sin theta. Divided by 1 over sin theta. So how do we do that? We now have what? Mg over divided by mg sin theta plus Fr times sin theta over 1. Now, having gotten that now, efficiency, now these are our efficiency. Let's break it down. So it will now be what? Mg times sin theta will now be mg sin theta all over what? Mg sin theta plus Fr. So now, all this is the what? Formula for efficiency in a what? An inclined plane. So this is a pure formulas or pure formula of what? Efficiency. And what? If they give us efficiency, you don't need to multiply by 100. But if they don't give us efficiency, you can multiply by 100%. If they don't give us efficiency, multiply by 100%. But if they give us, no need to multiply by 100%. So this is the total analysis of what? Inclined plane as a machine. So we are able to analyze the what? Velocity ratio when the friction, when you have a friction. We have analyzed the what? Mechanical advantage, and we have also analyzed the efficiency, and we have also combined the what? The case of what? Frictionless surface, where we have efficiency to be what? That means in an ideal case, this is an ideal case. And we have also talked about the practical case where we have a real case. Now, I believe you have enjoyed the class. Please ensure you subscribe. Thank you.